In this lesson, we're going to model multiplication and division word problems using fractions. There are several notes that I want you to write down as we start each word problem. I want you to ask yourself if we know the total, and if we know the total in the word problem, it's going to be a division problem. Or is the problem asking you to find the total, or are you looking for the total? If so, that's going to be multiplication. We also want to ask ourselves at the end of each problem, should our answer be getting bigger or smaller? And that's how we're going to estimate. Our first word problem says, each small cake takes 3/4 of a cup of frosting. If Ava wants to make 16 cakes, how much frosting will she need? So in this case, I'm going to ask if I know the total. Well, the question is asking about frosting, and it's asking how much frosting will I need. So in this case, I am looking for the total. This is going to be a multiplication problem. So before I start, I want to think, if I want to make 16 cakes, if I used 1 cup of frosting, a whole cup, and each cup made a cake, I would need 16 cups of frosting. But I'm using less than a cup. So when I open a cup of frosting, I'm going to use 3/4 of it, and there's going to be leftovers. So my answer should be getting smaller. I'm not going to need all 16 things of frosting to make 16 cakes. So because I am using frosting is what's being cut up, I'm going to start by modeling a cup of frosting. And it's really important to label as I'm drawing what I'm drawing. So this is a cup of frosting. And when I open this first cup, I'm going to cut it into 4 pieces. And they said that 3 of these pieces are going to be used to make 1 cake. So I'm going to put number 1 in 3 of these pieces, and a number is me counting cakes. So as I start to make my second cake, I can use this 4th, but I'm going to need to open a new thing of frosting, and I'm going to go ahead and cut it into 4ths. So that was 1/4. I need 2 more pieces. So here's 3/4. Now I'm going to start the third cake, and I know that I'm only going to have 2/4 here. So I'm going to open another thing of frosting, cut it into 4ths again. Now I have 3/4 for cake number 3 and 3 pieces for cake number 4. So right now I can look at this equally used amount of frosting, and right now the number is number 4. So 4 cakes have been made. And the circles are my cups of frosting, and there are 3 circles, so there are 3 cups of frosting. And I'm going to go ahead and draw a few more cups of frosting because I need to make 16 cakes. And I know I can cut all of them into 4ths. So I'm going to use 3 pieces to make cake number 5, 6, 7, and 8. And once again, I've evenly used up frosting, so I'm on cake number 8. And I've used 6 circles, so 6 cups. And if you notice, 4 doubled to 8, 3 doubled to 6. So I've only made 8 cakes. I have to make 16. So I'm going to draw a few more circles. I'm going to go ahead and cut all of them into 4ths. So 3 pieces for cake 9, 10, 11, 12, 13, 14, 15, and 16. So I can stop because number 16 means I have made 16 cakes. And in order to make 16 cakes, I'm going to count how many circles I used. And I can also look at the pattern. I know that 8 doubled to 16, so 6 would double to 12 cups. So using the model, I can see that 16 cakes would use 12 cups. And in order to check this with the algorithm, we said this is multiplication, and in multiplication, order doesn't matter. So this can be 16 times 3/4. And in order to solve it, I would put a 1 under my whole number. And I can multiply 16 times 3. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. So 48 over 4. And if I divide 48 by 4, it will go in evenly 12 times. Our next example says, each small cake takes 2/3 of a cup of frosting. If Maddie made 8 cups of frosting, how many cakes can she frost? So I know that it's going to take 2/3 of a cup of frosting, and Maddie has 8 cups of frosting. So that's all she has. She is not going to get any more. And so in this case, I'm going to ask if I know the total, and I do. The total is 8 cups. She can only use 8 cups. Since I know the total, this is a division problem. So I'm going to ask myself, what is being cut in this problem, and is my answer going to get bigger or smaller? So I know that she has 8 cups of frosting, and if 1 full cup made a cake, she could make 8 cakes. But she's only going to use 2/3 of each cup, so she's going to have leftovers, and she can use those leftovers to make more cakes. So she should be able to make more than 8 cakes, so my answer should be getting bigger. So in this case, I'm cutting up frosting, and if that's what I'm cutting up, that's what I'm going to draw. So I'm going to draw and label frosting, and I do know the total. She has 8 cups, so I'm going to draw exactly 8 cups of frosting. And my fraction is 2/3. So I know that I want to go ahead and break all of my frosting into thirds. Now I'm going to start making cakes. And 2 pieces of frosting are used to make a cake. So I'm going to start numbering cakes. So 2 pieces make cake number 1. I'm going to use that third to start cake number 2. And now cake number 3. 2 pieces for 4. And so on and so forth. Now that I've filled in all 8 cups of frosting, I've used up all of the frosting, and I arrived at number 12. So 8 cups of frosting will make 12 cakes. We said that because we knew the total, 8 cups of frosting, this was a division problem. Division order matters. So I have to decide, is this 2/3 divided by 8, or is this 8 divided by 2/3? And once again, I'm going to ask what was being cut up. The 8 cups of frosting were being cut up. And if that's what was being cut, 8 goes in the front. So 8 divided by 2/3. This is a division problem, and we know division, we use KFC. So keep 8, flip 2/3 to 3/2, and change division to multiplication. So I'm going to put a 1 under my whole number. 8 times 3 is 24. 1 times 2 is 2. And 24 divided by 2, that's a math fact, that is 12. So my final answer is 8 cups of frosting will make 12 cakes. And I can check it and see that my answer did get bigger. Our next word problem says, Hunter needs to make peanut butter sandwiches for 12 children. He wants to make 3/4 of a sandwich for each child. How many sandwiches does Hunter need to make? So I'm going to start off by asking, do I know the total? Well, the question is saying how many sandwiches do I need to make? So I don't know the total. I'm looking for the total. So this is going to be a multiplication problem. Now I'm going to ask if my answer will get bigger or smaller. Well, there are 12 children, and if each child got a whole sandwich, then I would need to make 12 sandwiches. But each child is going to get less than a whole sandwich, so I'm going to have pieces of sandwich that I can use as leftovers. So my answer should get smaller. So since I don't know my total, I only know that I need to make 3/4 of a sandwich to feed children. So I'm going to start by making my sandwich because the sandwich is being cut. I would not want to draw 12 objects because 12 was children. And if you started drawing 12 children, you would be cutting up children. And that's not what you want to do. So we want to draw a sandwich. So my square is a sandwich. And I know that each sandwich is going to be cut into fourths. And the number, every time I count, I'm counting for a child eating a sandwich. So my number is going to be the kid, or the child. So I made a sandwich. 3 of these pieces are going to go to kid number 1. And I need to make another sandwich to feed more kids. So I'm going to use this piece and 2 more pieces, so 3/4, to feed kid number 2. And I'm going to need to make another sandwich. So kid number 3 is going to get 3 pieces, and kid number 4 is going to get 3 pieces. So right now I have fed number 4. Number is kids, so 4 kids. And the rectangles are my sandwiches. So how many sandwiches have I drawn? I have drawn 3 sandwiches. And I need to get to 12 kids, so I'm going to draw a few more sandwiches. And I can go ahead and cut them into fourths. So 3 pieces go to kid 5, 3 for kid 6, kid 7, and kid 8. And once again, it's a good stopping point. So I'm at number 8, kid number 8. And I have now drawn 6 sandwiches. And I like to stop at these points so I can find patterns. So right now, my numbers are doubling. So I'm going to draw a few more sandwiches, cut them into fourths. 3 pieces for kid 9, 3 for kid 10, 3 for kid 11, and it works out perfectly. I have now reached 12 kids. So now I'm going to count my sandwiches. So 3, 6, 7, 8, 9. 9 sandwiches. So in order to feed 12 children, I will need 9 sandwiches. So my answer did get smaller, which is what I was expecting. And I can check this with the algorithm for multiplication. And we said multiplication order doesn't matter. So in this case, it doesn't matter if I put 3/4 first or 12 first. But this is 12 times 3/4. And with a whole number, I put a 1 under it. 12 times 3 is 36. 4 times 1 is 4. And 36 divided by 4 is equal to 9. So 9 sandwiches. Our last word problem says, Mr. McCullers has 15 cups of frog food. His frogs eat 1.5 cups of food each day. How long can he feed his frogs before the food runs out? Well, right now I'm going to ask if I know the total or not. It says Mr. McCullers has 15 cups of frog food. So in this case, I do know the total. This is going to be a division problem. And now I'm going to ask if my answer is going to get bigger or smaller. Well, he has 15 cups, And he's going to use more than a cup of food each day. He's going to use a whole cup and then another half of a cup. So could he feed his frogs for 15 days? No, he would run out before then, so my answer should get smaller. So Mr. McCullers has 15 cups of frog food, so I know that I'm going to draw my frog food, and I have exactly 15 cups. Now I'm going to start feeding the frogs, and I know that every time I do a number, it's going to be that he fed his frogs a day, so the number equals days. So my first cup of food I'm going to need on day 1, but I'm going to have to open another cup and also use half of it for day 1. So a whole cup and a half a cup. Day 2, I'm going to use half of this cup, and I'm going to use a whole other cup, so a half cup and a whole cup. Day 3 is going to get a whole and a half. Day 4 is going to get a half and a whole. 5, a whole and a half a cup. 6, a half cup and a whole cup. 7 is going to whole and a half of a cup. And 8, 9 gets a whole and a half. And then I'm going to give the last half and whole to number 10. So number 10 is the number of days. And I used up all 15 cups of frog food. So my answer is 10 days. And this is giving me a smaller answer. 10 is smaller than 15. And this is a division problem, and in division I know that order matters. So I'm going to ask what was being cut up here, 15 cups of food or 1.5 cups of food. And it was 15 cups of food, so 15 goes in front. 15 was cut up or divided by 1.5. There's several things I have to deal with in this algorithm to solve it. The first is that I have a mixed number. And the first thing I want to do is turn this mixed number improper. So this is going to be 15 divided by 2 times 1 is 2, plus 1 is 3. And the next problem is that this is a division sign, and I know with division problems I use KFC. So I'm going to keep 15. I'm going to flip 3 over 2 to 2/3, and division changes to multiplication. And the last step is to put a 1 under my whole number. 15 times 2 is 30. 1 times 3 is 3. And 30 divided by 3 equals 10. So it is correct with my algorithm. Now we're going to see how to write a multiplication sentence or an equation meaning it's going to need an answer, to what's being modeled above. So in order to figure out the multiplication problem, I'm going to start by looking at one object. And what fraction is being modeled here? Well, this object is broken into thirds, and one piece is shaded. So 1/3 is being represented. Now I'm going to count how many times do I see 1/3. So 1, 2, 3, 4, 5, 6. So 6 times. So this is 1/3 times 6, or 6 times 1/3. Order doesn't matter with multiplication. And in order to solve it, I would put a 1 under my whole number. And 1 times 6 is 6. And 1 times 3 is 3. And 6 divided by 3, it equals 2. So in order to write an equation, I want to write 1/3 times 6 equals 2. And I can see this on the model because I could combine pieces. So if I moved this one over here and took this one and moved it over here, this would fill up a hole. And then I could also move these two pieces over, and that would fill up two whole circles. Now let's try to write another multiplication sentence. I'm going to start by looking at just one object, and this first object is broken into fourths. 3 of them are blue, so 3/4 is being represented. Now I want to see how many times. So 1, 2, 3, 4, 5 times. So this is 5 times 3/4. And in order to solve it, I would put a 1 under it, under my whole number. 3 times 5 is 15. 4 times 1 is 4. And that is an improper fraction. 4 goes into 15 3 times, and 3 times 4 is 12. With 3 left over, the remainder becomes my numerator, and 4 is the denominator. So, to write my final equation, I would say that 3/4 times 5 equals 3 3/4. And I could see this if I rearranged it in the problem. I could move this blue piece to fill up the first rectangle. I can move the second blue piece to the second rectangle, and this third one to fill up the third. So this would now give me a hole right here, 3 holes total, and then 3 out of 4 pieces left, which is 3 3/4. The last type of model we're going to look at is if I'm given a shape, in this case the rectangle, and it tells me the entire rectangle is 2 feet long. I need to find the length of each circle, and the circles perfectly match the distance of the 2-foot rectangle. So the first thing I want to do is count how many objects, how many circles are divided up between this 2 feet. And there are 1, 2, 3, 4, 5 circles. So in this case, a 2-foot rectangle is being divided by 5 circles. And I know that fractions are a division problem, so I could write this as 2 divided by 5. And if I wanted to, I could turn this into a decimal, but I actually want to leave this as a fraction, and this is my answer. And I can check this because if each circle was 2/5 long, I could check this with multiplication or addition. 2/5 times 5. 2 times 5 is 10. 5 times 1 is 5, and 10 divided by 5 is 2, which is the 2 feet that I started with. Or I could just add this up. 2/5 plus 2/5 is 4/5, plus 2 more is 6/5, 8/5. 8/5 plus 2/5 is equal to 10/5, which once again equals the whole distance of 2 feet. So in order to solve this problem, I looked at the whole distance of the rectangle, which was 2, and it was divided up by 5 objects. Let's try one more example. In this problem, my rectangle is 1 inch long, and there are 3 circles underneath it. So if I want to know the distance of each of these circles, I'm looking at 1 inch being split up or divided up by 3 pieces. And this looks like 1 divided by 3 as a fraction, which is going to be my answer. So 1/3 plus 1/3 plus 1/3, or 1/3 times 3. Either way will equal 3/3. And I know the simplest way to say 3/3 is 1 inch. So each circle must be 1/3 of an inch long.